next two examples, we're going to look at two sets of data and writing a linear equation to describe that data. Just to confirm that this is an actual linear set, I'm going to find the rate of change between each set of points. And remember that if it is a linear relationship, that rate of change should be constant, should be the same for all three of these pairs of points. So, again, I'm going to think of the altitude as the dependent value, because the altitude depends upon the time. So the time is the independent value. And again, as discussed in 5.1, the rate of change is the change in the dependent variable or values divided by the change in the independent value. So, starting here, we take 590 minus 640, which is negative 50 over 20. So that's negative 5 halves, or negative 2.5, which means that that's negative 2.5 meters per second from 10 seconds to 30 seconds. Doing the same thing with these two, 490 minus 590 is negative 100. 70 minus 30 is 40. And again, that's negative 5 halves. And finally, doing the same thing between 70 and 90 seconds. 440 minus 490 is negative 50. 90 minus 70 is 20. We get negative 5 halves. So, since that is constant, that means that this is a linear relationship. So, wanting to write it in slope-intercept form, a couple of different ways you can do this. You can write it in the point-slope form first, and then get y by itself. If we wrote this in point-slope form, we choose one point. I'm going to choose this one where the numbers are the smallest to work with. So, in point-slope form, the y value would be 640. The slope is negative 5 halves. And then x minus 10. The x value would be 10. Remember, change the sign. So now what you can do is to write this in slope-intercept form, you can distribute the negative 5 halves. So y minus 640 is equal to negative 5 halves plus, x plus, we have 50 over 2 when we multiply that. So that is 25. And then finally, to get the y by itself, we add 640 over here, so that will be added here, and to the 25. So when we do that, our slope-intercept form ends up being y is equal to negative 5 halves x plus 665. Now, the slope is negative 5 halves, or negative 2.5. So what that means in this situation is that the balloon's altitude is decreasing at a rate of 2.5 meters per second. That's what that represents. It's decreasing because the slope is negative, and it's decreasing at a rate of 2.5 meters per second. Now, the y-intercept, which is 665, That's where the balloon is at time equals 0. So when it starts its descent, that is where the balloon is. So the y-intercept means that the balloon's altitude was 665 meters when it started its descent. So that's what the y-intercept and the slope means. Now, the next example, it shows the number of gallons of water in a tank after a given number of hours. And again, just to confirm that this is a linear relationship, I'm going to find the rate of change between all three of these points. So, the 4570 minus 3320, we have 1250. 3 minus 2 is 1, so that's 1250. Rate of change between 3 seconds and 5 seconds. I'm going to take the 7070 minus 4570, and I get 2500. And then the change in the number of seconds is 2, 5 minus 3, so that's also 1250. And finally, between 5 and 8 seconds, I'm going to take the 10,820 and subtract the 7,070 to get 3,750. And this time the change in seconds is 3 seconds. So I'm going to divide that by 3. I also get 1,250. So the rate of change is constant. And so the slope is 1,250. So once again, I'm going to write this in point slope form. I'm going to choose the point with the smallest numbers. So we have y minus 3320 is equal to 1,250 times x minus 2. And we're going to start solving this for y by distributing the 1,250. And finally, we are going to add 3,320 to both sides to solve for y. So, our final equation in slope-intercept form is 1,250x plus 820. So, the slope, which is 1,250, means that the tank is filling at a rate of 1,250 gallons per hour. So the amount of water in the tank is increasing at a rate of 1,250 gallons every hour. So each hour that goes by, there will be 1,250 more gallons in the tank than there was the hour before. The y-intercept, which is 820, that's at time 0, at the starting point. So when we started filling the tank, there were 820 gallons of water in the tank. So there were when we started filling the tank. And that's what the y-intercept means. The slope is how much it's increasing or decreasing per unit. In these two cases, it was time. And that y-intercept represents where we started. What was our starting point? In this case, we started with 820 gallons in the tank when we started filling it up.